Howdy, my name is Korok Ray. I am a professor at Texas A&M in the Mays Business School and director of the Mays Innovation Research Center, which is sponsoring this podcast, Innovation Matters. Today, we're delighted to welcome Chad Sparks and Jason Hurst of Bell, which is used to be called Bell Helicopter, but is one of the original players in aviation. And we're here to hear about their a little bit about the genesis of the company and where they are now. Welcome, Chad and Jason.
Thanks. Appreciate it.
Great. So, tell me, Chad, just to start off, you came to A&M. A little bit about your journey here and your major in aerospace. Can you tell us a little bit about why you did that and how that came to be?
Yeah, like most young burgeoning engineers, I anchored myself as a young child on Legos and just loved everything about what I imagined, this creative space in engineering to be. I dreamed of being an astronaut, like many young children, and that led me on a really clear path towards aerospace engineering. I wanted to be a part of that industry. I wanted to be a part of the space community in particular, and so that's what set me on a path from the small town I grew up here in Texas in Victoria, and then found myself in College Station just a few years later.
Great. And tell me a little and briefly about your career afterwards.
So as I went through the degree program at A&M, I did co-op here, and so I spent time actually working with Johnson Space Center in Houston as a co-op engineer, and thought I had a trajectory in space, but then things shift. Sometimes your career path isn't quite as clear as you thought it was going to be, and NASA went on a hiring freeze, and I looked at a different vector and found by interviewing at Bell and seeing some of the amazing work that they were doing at the time, I took the leap into the world of rotary wing and rotorcraft, and that allowed me the opportunity to progress in engineering for about the first decade of my career at Bell. I spent a lot of time in survivability, so blowing up a lot of stuff, doing a lot of signature analysis and things for our defense customers. But then, from there, really progressed into some broader business parts of my career. And so over the last decade and a half, I've spent time in supply chain, I've spent time in program management, I've spent time in business development, and today I find myself in a role that's this combination of both strategy and really thinking about deeply in how the company aligns resources within the organization.
Great. And Jason, tell us what your role is now at Bell.
So I'm the Vice President of Innovation for the company, so responsible for all research activities for both the defense and military side of the business and for commercial products.
Okay, great. And maybe, Jason, could you tell us what we're looking at here? Maybe tell us what's on the screen.
So sure, this is a family of systems that's for what we call our high-speed vertical takeoff and landing. So it's that's not something that's new for Bell. Bell has a lot of deep history in high-speed aircraft, even the S.1, which is the first aircraft that broke the sound barrier. And then with the V-280, with the 525, and with the Bell 360, we have the highest speed rotorcraft in the world. At some point, you reach some physical limitations with those configurations. So this is really the next generation beyond the current FVL efforts to reach new speeds and go over 400 knots with an aircraft that has a true vertical takeoff and landing capability.
Great. Now, Chad, who are your primary buyers of these aircraft?
Well, for aircraft like this is primarily defense customers. They each and every day we've got whether they're Marine Corps operators or Air Force or Army, get up and utilize rotorcraft every day in order to move people and goods to wherever they need, both in the battlefield and really even in humanitarian aid and relief efforts. And so, vehicles like this are all about how do we get speed and range so that our defense operators can be even more effective in what they do every day.
Okay, so you don't really have a retail customer yet.
Correct. This high-speed vertical takeoff and landing is not primarily, at least as an entry point, a commercial customer opportunity. Generally, what we see in our industry is this evolution of cutting-edge technology, generally driven by our defense customers, that we then pivot into our commercial business. It's nice with Bell being a fairly balanced business of almost 50-50 portfolio between defense rotorcraft and commercial rotorcraft that allow us to apply dual-use technologies in those ways.
Okay, great. Jason, tell us a little bit about innovation at Bell, which is kind of your home department.
Sure. So team was launched about 5 years ago to really look at what are the over-the-horizon technologies, how can we be disruptive? Because the world we live in, as Chad described, it's very mature technologies, mature markets. So the areas we're focusing on with our research efforts, with our experimental aircraft, are in the areas of autonomy, electrification and hybrid electric aircraft, and also unmanned systems. Well, our team is also responsible for all advanced concepts. So any future military or commercial variants, things like you see there, all of that's generated from our team. Then we identify what technology gaps we have to make those possible. And at the point that we close those technology gaps, we hand those off to the product and business owners. And our team rolls into what's the next area of research focus.
And a lot of this innovation is your R&D is all done in-house. Do you acquire smaller startups on a regular basis?
We've been fairly selective on acquisitions. Our corporate parent does a lot of that activity for us. We recently acquired Pipistrel through our eAviation division, which actually has the world's first and currently only certified electric aircraft. And so we do things where they're necessary like that, but mostly we do a lot of our research internally and through partnerships with universities, as well as partnerships through a lot of the DoD research labs.
So actually, that was one of my next questions. I mean, and either of you can take it, is about the electric aircraft. How far are we from that technology? Does it exist? Will it scale at larger aircraft? What do you think?
So absolutely, you'll see that it's starting small. A lot of the challenges we have with electrification are in the effective range of the aircraft. Obviously the fuel is way less energy dense than liquid fuels we use today. That being said, that's going to improve over time. So what we're doing is figuring out what is the architecture, what are the safety standards we need to meet with electric aircraft, and then starting small and growing it. So if you look like an example, we have the first electric aircraft that we're looking to deliver on a Bell side is a 400-pound cargo drone. We call the APT for autonomous pod transport. And we've flown that in several real-world operational scenarios. We've flown it in the desert. We've flown it in the jungle. We've even flown it into a populated neighborhood to simulate a cargo delivery. And we're looking to what are those pilot programs that will prepare that to be a disruptive force in the market.
Chad, do you see the electric airplane or the electric helicopter to be the future of aircrafts?
I think there's going to be a synthesis of several concepts. It's all about ultimately the customer value proposition. The things that are interesting about the electrification of propulsion systems in particular is that there's a simplicity that comes with it in design. There's the opportunity to potentially reduce operating costs in those areas. But to Jason's point, the full capability set is not there compared to conventional turbo machinery today. And so I think you'll see a meshing of those as capabilities grow within the electrification side of the world. You'll begin to enter more and more of the traditional markets, but I think for quite some time you're going to see a hybrid of both. You'll see traditional turbo machine aircraft that are able to do many of the missions that we do today because of either the payload or the range that's required. But the electrification ones are interesting in that I think there's an opportunity to actually create some new use cases that maybe aren't being served today that'll be some of these early entry points into the market. Jason talks about the APT vehicle and where we see it fitting. It's a really interesting space in that unmanned cargo logistics is an emerging market. So you're talking about disrupting not just traditional aviation industries, but even ground-based transportation. How are we delivering medical supplies in infrastructure challenged areas? I see things like lab specimens and vaccines being transported in places like sub-Saharan Africa using drones now that would have been a 10 or 12-hour trip by ground vehicle. You're now doing in 30 or 40 minutes with an unmanned vehicle.
Are you finding that maybe in other countries that are either less developed or less regulated, it's going to be easier to deploy that technology than here in the U.S.?
Yeah, to me, it all matches up with what's the use case. Certainly, because of the environment that we see here in the U.S. and the robust infrastructure that's here, and the regulatory climate that we see here, there are certainly a set of challenges that come with that. In some of the more undeveloped parts of the world, generally you've got a cross section of trying to find the right use case with the right economics in the right regulatory environment. And so we're seeing today a bunch of different points of light that are out there. So very small, limited use cases that we're seeing be applied. Very few of those are in what I would consider a revenue-generating opportunity. Most of them are in early pilot programs, either proving the technology or they're approving early business models.
Yeah, I wonder if we'll see what happened with aircraft, what we saw with phones, which is that these less developed countries sometimes skip the landline.
You'll get some leapfrogging.
And went straight to the mobile. Yeah.
A lot of the use cases Chad's highlighting is a lack of infrastructure.
Yeah.
Which ties into the phone example as well. But if there's not a road network,
Right.
or if it and that could be in developing countries, but it also can be in more remote areas domestically as well. Some of the other use cases we see are for supporting mining operations, supporting hot-shotting things, support farming operations, things that how does it beat the next best alternative from a business perspective? Is it saves you time if you have machines that are down or certain areas that need resupplied. How can you resupply faster and get them up and running again?
Is Bell involved in personal flight? And if not, how close do you get to that area of personal?
I'd say from a personal flight standpoint, the closest we get to that today is really in our conventional rotorcraft. So we have the Bell 505, which is basically a 5-passenger turbine helicopter.
Yeah.
So it's sort of the entry point into traditional vertical lift space.
Yeah.
We generally consider that the clients that we see or the customers that we see for that aircraft is generally a cross-section of personal ownership models. There's corporate models. We're seeing some early parapublic and police and folks that are in that space as well. But in terms of what I would consider kind of true personal flight, like vehicles that are one person to one vehicle, generally we have somewhat shied away from that space just because some of the economics around it are really challenging to converge on, and where Bell really has its strengths are on commercially derived aircraft that require a really robust certification process, a really robust engineering, manufacturing, development process that's driven into vehicles that are generally larger than a personal vehicle space.
So that 5-person helicopter you mentioned, that is, are we talking like the hospital helicopter or a police helicopter? Is that roughly the size and scale? Or?
Yeah, I would say the hospital and police helicopters generally are a step size larger than that.
Okay.
Bell actually has a portfolio of commercial aircraft, the 505 being the smallest of those.
Okay.
Going up one kind of step beyond that is the Bell 407. Generally, you can load a single litter into that aircraft and provide it for hospital transport. And then as you go up to a twin engine aircraft in the Bell 429, you'll see a larger cabin, more space to operate in. And we work very specific requirements for aircraft like that. So ride quality in the case of the 407 or the 429 is really important. If you're attempting to do any kind of medical procedure while in transit, something as simple as just inserting an IV, you want super smooth ride quality as part of that. So we've got a lot of great engineers that they spend and hone a lot of their time and energy on providing really great damping technologies to ensure that you've got the best possible environment for medical care.
Okay. Let's talk about autonomy. Solving the autonomy problem in the air is conceptually simpler than on the ground, less the obstacles. Are all of your helicopters able to be fully autonomous?
So where we're starting right now is working on the core technology that is going to create our foundation for autonomy. So that's one of the focus areas for my team.
Okay.
The interesting thing about our business is that actually scales across commercial and military business both. In all the FEL modernization, we have requirements for either optionally piloted operations and potential for fully autonomous. And then in the commercial space, we see that as a potential for a safety and pilot workload reduction.
Okay.
So we're working on the architectures. One of the new technologies we're bringing to the commercial rotorcraft market is fly-by-wire technology.
Right.
That's starting with the Bell 525, and that will inherently have the architecture that enables autonomous features. On your comment about the differences between the air and the ground, there's an example I like to use a lot of the times of if you're in the air and you have detect and avoid system and you see something in the air, to avoid it. You don't wonder, is that something that's an issue or not? It shouldn't be there.
Right.
However, if you're on a ground vehicle and your radar lidar scans something, it has to decide, is that a feather or a brick?
Right.
And it has to decide, am I going to take an extreme action to avoid that?
Right.
The interesting thing about what helicopters and rotary wing aircraft have against fixed wing aircraft is fixed wing aircraft are coming and going from established runways, known locations.
Yeah.
The reason you have rotorcraft is to have the flexibility to land anywhere you want to.
Yeah.
So we actually have to have the decision systems on board, the perception systems on board to evaluate landing zones, select landing zones, and to safely ingress and egress from landing zones. So we actually get a lot of that, the need for that ground sensing on rotorcraft because of where we operate. Especially when we talk about, like we talked about the, developing countries or less infrastructure of needing to go out somewhere that's not well mapped, well defined,
right,
and being able to have the aircraft sense where it is and be able to make decisions based on that sensor. There's a big difference between automating something, which is repeating a task with known inputs, versus making something truly autonomous where it senses and makes a decision and responds accordingly.
But it sounds like you're not there yet. You're not the helicopters are not yet fully autonomous.
Right. So we're flying the unmanned system autonomously. We tell it, go from here to here, and it maps the route, does that. Then that will scale up into the helicopters. But the helicopters we're delivering today do not have autonomous features on them.
Okay. And
that's why we're working on the research team, is to develop that and build the roadmap to implementation. And we're looking for some, near-term big impact things of, how do we prevent, any sort of safety incidents, things like that. How can we make our rotorcraft safer on the commercial side? And then on the military side, it's going to be about, productivity and and then also what's the, risk profile of a mission. Is that something they want to send a pilot into or not?
How far away are we from full autonomy on most of your aircraft?
So
what would you say?
Full autonomy, some of that's a business decision
Sure.
of, what's the acceptance rate from the pilot and operator community. I'd say from a technology standpoint, I think you'll see that maturing exponentially over the next 5 to 10 years.
Yeah. Okay. I'd add one piece of it too that I think is important. When we talk about autonomy, it's often easy to sort of blanket state about implementing autonomy. Autonomy to me always has environmental context, use case context that comes with it. So the amount of environmental sensing and decision making you need for an aircraft that's going to fly over a fairly desolate mining operation is different than what you would necessarily need for an aircraft that's flying over an urban landscape like the Dallas-Fort Worth area. And so we often think about levels or layers of autonomy that are all framed within the context of the use case that you're trying to implement.
So let me play devil's advocate here. I mean, if you guys have a long, probably the oldest helicopter company around, at least that anyone knows about, and you have been established leader in pilot-based navigation. Are you guys the right company to be doing a fully autonomous rotorcraft, or should you kind of start from a clean slate, have a new startup say we're going to just focus exclusively on that from the? Is it?
Yeah, I'd say it's important when we think about legacy with a company like Bell that's got 85 years in developing rotorcraft.
Right.
We spend time, Jason and I spend a lot of time thinking about what are the new core competencies that we need in the organization, because it is an important shift in how we are thinking about the future of the organization. It's why you establish things like the innovation team, so that we have this sandbox, we have this maker space to develop new core competencies. And so for such a fundamental piece of where we think the future of aviation is going, which is some layer of autonomy and some layer of simplified vehicle operations in the future, it's an area where we know investment is critical, and we are going to build competencies around that. Now, there are lots of ways that we have started to pursue that. Some of that has been in small partnering with startups, so we certainly evaluate that community and see the work that's coming. But much of that focus is building up internally those capabilities so that we understand how to truly integrate onto our platforms in an efficient way. The risk of sort of bifurcating those is really around can you truly integrate the right way to create the system efficiencies and ultimately the system safety around that.
And I think it's also, I actually think that's a fantastic question, and I don't think I've gotten that one before. Usually it's what are we doing, not who should be doing it. So if you look from a historical perspective, Bell actually led the way in a lot of the unmanned rotorcraft autonomy. We had a program called Eagle Eye, which was flying autonomously in the late 90s, early 2000s. So we actually, when I managed the V247 program, which was the last one that I had prior to this role, we leveraged a lot of the technology that we developed 10, 15 years ago to be able to have a head start. And then what we're doing now is looking at a broader perspective of how do we take that and advance it. So I absolutely think we have the right background, and as Chad said, it's tightly integrated into the entire aircraft system. And so I think for us to have a guaranteed level of safety, then that's going to be an absolute necessity to understand and implement that ourselves. And I think what you'll see is from a shades of gray perspective, it's going to be a lot like you've seen in the automotive industry, where you start with sensors that give pilots a warning. Like if you have a car that has the lane departure warnings, we're going to give pilots feedback of, hey, we have new systems on board. They can give you feedback, an extra set of eyes, different wavelengths, frequency than your eyes operate at. They can give you a warning system. And then that transitions into not just giving you a warning, but actually taking evasive action for you, down the road. So that it'll get into the levels of autonomy Chad mentioned. It doesn't just start off with the airplane flies. You just push the button and flies itself. It starts with, thousands and thousands of flight hours of collecting data on how the system's performing and providing the warnings prior to providing the command inputs.
Yeah, and I'd add one other piece to that. When you talk about Bell's positioning in this space, one of the very first fundamental pieces of implementing autonomy is about fly-by-wire technology.
Right.
So,
can you explain what that is for our audience?
So for the audience, most traditional rotorcraft today are controlled from the pilot input to the rotor head through some form of mechanical linkage. In newer generations, when we implement fly-by-wire, there's basically an interpretation from the pilot inputs into a flight control computer that then sends just electronic inputs to an electromechanical actuator at the rotor head. And so that gives you the ability to do a lot of additional things in how you manage the flight profile of the aircraft. And what's important in terms of Bell's positioning in this space is we are on the edge of certifying the first commercial fly-by-wire rotorcraft. And to me, that is one of the very first building blocks of how you truly roll out some level of autonomy commercially in the space. Again, there's a lot of great technology development that's happening across the industry, but to really get something over the finish line in a certification basis is, in our opinion and our experience, there's hard work that has to be done there to get there, and to be one of the first ones over that finish line is really important for us, and I think positions us well for the future.
Now, both of you have been in this industry, and in fact, this company for a long time. Let's skip past the transitional period, and if I force you to make a prediction, what will be the equilibrium or steady state use case or operating features of an autonomous rotorcraft helicopter? How autonomous will it be? Do you really think that it'll ever be fully autonomous? It'll just be an assisted will the pilot still have to have the pilot controls and the pilot seat there?
So I would say we have the technology to be able to fully control the vehicle today. One of the autonomy demos my team did was we had a moving platform. So we were pulling a trailer and we controlled a drone autonomously to make a landing approach and actually land on a moving target.
Right.
Full stop. So we're able to do that today. The part we've got to get through is what's the regulatory environment, what's the level of safety required, and what is the public and pilots' acceptance of that. So what you'll see eventually is the ability to combine autonomy with the fly-by-wire technology, have full vehicle control, and the role of the pilot will shift. For some period of time, there's going to be a requirement to have a fully trained, fully capable pilot on board that can always be a backup system.
Right.
We'll get past that eventually. But what will happen in the pilot's role over time is it will transition from a aviator to more of a mission manager. So if you think about helicopters are used for search and rescue, especially like offshore, Coast Guard missions, things like that. Right now, the pilots have a heavy workload to be able to fly the vehicle.
Right.
They will be more of monitoring the aircraft as it flies, and they'll also be participating in the search function.
Yeah, I see.
Instead of being heads down and flying.
Right.
Same thing on the military side. They will be part of mission command and part of the battle rhythm.
Yeah.
Instead of aviating, they'll be managing. And supervising what the aircraft's doing, but not actually required to be task saturated doing that. So it frees the pilot up, since he's there, to be able to participate a lot more in the function of the mission instead of just providing command cues to the vehicle.
So it sounds like the bottleneck is not the technology; it's really social norms and regulation.
Right? So it's a combination of all the above. So technology is in development. It has to have a level of reliability and redundancy. It has to have the regulatory environment. and you have to have the public acceptance. I mean, and one of my favorite things to watch is the folks that are early adopters that are taking the autonomous taxis.
Yeah.
And there's some pretty good comedy that's ensued from when the autonomous taxi breaks down and they're stuck in the back seat,
Right.
or it pulls out into construction zones and doesn't know where to go.
Yeah.
We don't have that luxury in aviation to do
right.
that. So there's not a breakdown the lane in the sky.
Yeah. Yeah.
But anyway, so the public acceptance piece is a big portion of it. But I would imagine if we have an airplane that will be able to fly fully autonomously by the end of this year.
Oh, wow.
If I offer free rides in that with no pilot on board, I doubt I'm going to get many people that accept that right now.
Right. I guess the test with all autonomy is: are you willing to put your kid in the?
We've all had that exact discussion.
And I think one of the great examples of what the progression I think will look like is that acceptance around autonomy. We believe will start with cargo, by and large, much like traditional aviation did back in the day.
Right.
That there'll be great use cases for cargo missions that will build confidence in the technology. It will exercise the regulatory system. It will get community acceptance to a point where they feel confident, right? Where I can put my 9-year-old on the aircraft, without a pilot on board and feel good about that. But we think there's some time to be had before we get to that point.
Right. Let me ask you about sort of where we are in the life cycle of aviation innovation. So, I mean, kind of dialing back the clock, I mean, more than 100 years ago with the Wright brothers, we had breakthrough radical innovation. And you could say maybe the same thing with the jet engine. But it seems to me that there's kind of been a long time since then, and aviation has kind of stalled, no pun intended. What's the next breakthrough, and what's holding us back?
So I would say you've seen electrification changing the landscape of a lot of complex industries.
Yeah.
So for a long time, you saw in the automotive industry, and there's a lot of corollaries there of consolidation, and there weren't new car companies showing up. The amount of investment to develop a 100,000, 200,000 mile internal combustion engine and transmission and pass all the crash tests, the barrier was too high. Now with electrification, if you saw at CES this year, there were 10 new car companies that you'd never heard of before. Even Sony is in the car business now.
Right.
And so you see the same thing happening in aviation. There's multiple new aviation companies because there's a new technology that is a breakthrough and disruptor that is creating new possibilities. So there's aviation and rotorcraft companies that didn't exist 5 years ago.
And that breakthrough is the electric motor.
Oh,
that's right.
The advancement of battery technology to a level where you can start to use that for electric propulsion. And then we're also looking at other energy storage options like hydrogen storage and things like that. There's multiple ways to store and generate the electric power that you're looking for. And so it's kind of created I'd say it's almost like a second golden age of aviation where you have all these new concepts, all these new prototypes, and a huge portion of them will never go anywhere.
Right.
But it's a fascinating time as we experiment. And the reason we test and experiment is we don't know the outcome.
Yeah.
So I think we're going to learn a lot. If we look at this 5 years from now, a lot of the dust will have settled, and we'll see what are viable concepts, and how are those ready to go to market, and versus what were ideas and experiments that not all of them panned out.
Yeah, I think even just to give a perspective on the explosive growth in the creative space that distributed electric propulsion has unlocked for aviation. I think a quick search, and I believe it's the Vertical Flight Society has a website where they sort of track all these new concepts that are out there. I think last count there was more than 400 new concept vehicles that were somehow leveraging distributed electric propulsion in some fashion for any number of use cases. But I think that's a key indicator of, to Jason's point, the number of new sort of startups in the industry, the amount of capital that's coming into the industry. There's been several really significant SPACs that have been funded over the last couple of years that I think is an indicator of there's disruption in the aviation industry, and this piece of technology is a key enabler of that.
I'm a labor economist by training, so I want to let's switch to the labor market, which to me is about people. Okay, let's talk about maybe Jason, you can take this first, about what skills do you feel like are very valuable for innovation in space?
So I'm going to give you a little bit of context for it.
Yeah.
You mentioned that there hasn't been a lot of at least outward change and innovation in the aviation space. I think you've seen as evolution, natural selection of air vehicle designs has settled in.
Mm-hmm.
You've seen, the basic design of a helicopter with a big rotor and a smaller tail rotor for anti-torque, and the layout of a commercial jet.
Right.
You're picking at the edges of the
Yeah,
margins.
yeah.
So a lot of what, obviously that's still it's critical and important, but there's not as much opportunity there.
Yeah.
So what you really see is innovation in the digital and electrical side
Sure.
of the aircraft. So the aircraft are becoming much more integrated. So software skills, electrical engineering skills.
Oh, interesting. Yeah.
And even chemical engineering
Uh-huh.
as we get into mass production of batteries and
Uh-huh.
how you safely integrate, package, and secure those in the aircraft.
Okay. Chad, tell us a little bit about looking back at your career and your time at Texas A&M. What was useful about your degree? What could A&M have done better? What would you tell current graduates today, say in aerospace, if they were to walk into this industry now?
Man, it's such an interesting space now, and certainly the industry has evolved quite a bit. I reflect back on the time when I was in the aero program, and I felt like I came away with a really sound foundation of just good, solid problem-solving skills. That's probably what has served me best throughout my entire career. It wasn't that I could derive a particular formula or could regurgitate some calculus. It was about just having good, sound practice in how you sort of attack a problem, how you use data-driven decision making to come to good conclusions. The things those have been some of the things that have been most valuable, I think, in my career. When I look back on what maybe I wished I could have gotten out of my A&M experience, it would have probably been I struggled thinking I was on a certain trajectory into the space industry and not sort of taking the time, and part of this is on me, part of this is maybe on the way the curriculum was designed, but how do I experiment in some other areas to understand? Maybe I've got other passions, because what I found when I dropped into my first job at Bell was there wasn't a class I had taken on ballistics or survivabilities or signature analysis. At that point, it was all, did I have good sound engineering practices, and could I learn on the job? And so, I think there's a piece that if A&M could instill more of a, how do we create a mindset of continual learning? It's not just you get done with your degree and then I'm rubber stamped and I'm on to my career. What served me best throughout my career is having more of a continual learning mindset. I took a couple of years off from school after I started my career at Bell, and then I went back. I went and chased a graduate degree in aerospace engineering, just because I wanted to bolster more technical skills in areas that I had learned on the job that I knew were relevant then. And then I took a couple of decades off before sort of reinventing myself again in a learning environment where, because I'd had all this breadth of business experience, I wanted to learn more about, candidly being a corporate entrepreneur. How do I have an entrepreneurship mindset within a larger organization? How do I help us advance? And so complementing some of that engineering capability in an early degree with a little bit more of how does this impact the business world at the end would have been a couple of interesting caveats to me in how to advance the degree.
Okay, last question. What have the Aggie core values meant to you? How have they impacted your life?
Oh man, Aggie core values to me, I have always appreciated that. Aggie core values have such a strong moral compass to them, and you find in various corporate environments that those values don't always hold true with other folks. And so having great partners like Jason and I have known each other for a number of years, and having a trust relationship with him, and knowing that we can have great collaborative conversations. I think Jason and I talked more than once about we can disagree and we can argue and we can still be friends at the end of that, and knowing that there's this professionalism that comes with being part of Texas A&M, and having that sort of Aggie spirit about how you conduct yourself in business each and every day, to me, was a really important lesson I've just carried throughout my entire career.
And I guess the reveal preferences.
There is an indication at this point, and so the third one is now predestined. But yeah, I've got two of them here already, so I'm looking forward to continuing to be a part of this university community.
Great. Well, I want to thank both of you, Chad and Jason, for your time today. This has been a really exciting deep dive into aviation. Actually, we hope we'll have more of these. If you are watching, we do have on our YouTube channel, we have we did a fireside chat with David Mayman of Jetpack Aviation, and I think we'll probably have Ben Marcus from Up Ventures later this year. So hopefully this will be part of a little series we'll have on aviation. Thank you to both of you for coming on.
Absolutely. Thanks.
Great.
Appreciate it.
Awesome. Great. Thank you.
You bet.